Hi guys. So in the previous video, we have seen different kinds of what do we say types of operating systems, and then we have understood the I card of the process, which is process control block. Now in this video, we're going to see process states and schedulers. I think you remember in the process control block when I was talking about the I card, the first thing we noticed is process state. Now for process state, I said that it is a current activity of the process. Right? So what does it actually mean? As a process executes, it changes its state depending on the current activity. Now, what are these activities? Right? So let's just understand these activities. So there are namely 5 types of activities, right? 5 types of states, but there is an additional state which we'll learn it later after learning these, right? So the first one is new. Now, what is new? So, right. So whenever there is a process which is just came, which is not given instructions, nothing, it's just created. The newly created process is said to be in the new state. Now, as it was in a new state, now there will be some instructions given what to do, what not to do, right? And which is ready to be executed. So, one was normal, newly created, and the other was ready to be executed, right? Ready to execute it. Now, third one is running, which is in execution, right? Which is in execution. Now, the fourth one is waiting. Now, we'll understand everything, how this will happen, right? Waiting means for waiting something to happen, and terminate means finishing. Now, these are the states we generally name them, which are important. Right now, how this happens. Now you can see that there is the complete block diagram of these states. Right? You can see it. Now, what is this complete block diagram? You can see that right? So my process, which is newly created, is here, right? So it is here. Now it is generally admitted into ready state where it will be given all the instructions which it will be needed. Now once it is in the ready situation, when it is told what to do and what not to do, it is generally loaded into the running state. Now what does running means? Which is in the execution, right? Now after coming into the running state, once it runs successfully, it will complete the process, it will terminate itself, and it will exit. This is the one case which is the normal case. Every process go through this state. Now there comes the second part. Everything was fine until the new process was created, right? Loaded into ready, then it was scheduled, dispatched into running state. After that, there will be an interruption. At running, there will be actually 2 kinds of interruption, right? So one is this interruption. Now, what is this interruption means? Imagine I'm running a process, right? Imagine I'm running a process. Let's just say I've opened Instagram in my laptop. Right? As soon as it was opening, but I pressed a power button, right? So power button shutting off is important. Shutting down is important. So it will interrupt the opening Instagram command, and it will send shutting down process first. So whenever higher based or high priority based processes come into picture, already running processes get interrupted and then get back to the ready state. This is one. This is the second condition. First one was simply getting terminated. Second one was coming back to the ready state. And third one is IO event wait. So input and output devices event. Until unless input and output devices are available for us, we cannot say anything. So until unless they are not available, there will be a state called waiting state. Right? Now, once this IO events are done, when they are completed, they will be again into ready state, and there will be again, they will be transferred into the running state. After that running, they'll terminate themselves. So this is going to happen. This is the normal cycle. Now, these are the main states. There are other 2 states. right? There is one other state which is important, which is known as suspend wait. I'm sorry, which is a suspend wait. Now, this suspend wait actually present under the waiting thing. Why? Because sometimes whatever the cues, generally we whatever the states we are taking, whatever the processes we are loading are present in a queue format. You know, the queue data structure is the same, the queue format, they'll be, present. So whenever we are talking about the IO event waiting, input output devices waiting, so sometimes there might be a chance that this waiting hall might be full. So it will temporarily stop, pause all the processes and load them into this suspend wait state so that they can have an extra space for waiting and can wait until the IO are available. That is what happens. This is the additional state. Now, getting back to process states, now we need to understand schedulers. We learned what are states. We have 5 namely and another one which is the suspend wait. Now, talking about schedulers, generally we have 3 kinds of schedulers. 3 types of schedulers you can say, right? 3 types of schedulers. One is long-term scheduler. Second one is short-term scheduler. And the third one is mid-term scheduler. Now, what is long-term scheduler? Long-term scheduler generally take care of, loading as much possible as processes into ready state. I mean, like how many processes it may be possible, all the processes it should load into the ready state, right? Exactly, just into the ready state. So when these things happen, it is known as multi-programming. So degree of multi-programming is taken care by long-term scheduler. Long-term scheduler picks all the processes from new states and drop them into the ready state, or to be precisely, I would say ready queue, to increase the degree of multi-programming, which means there will be huge number of programs in the ready states which are ready to be executed, right? So that's why that is known as degree of multi-programming. Now, what does short-term scheduler does? Short-term scheduler does whatever the programs which are present in ready state, they are generally loaded into the running state. Now, it does not load, short-term scheduler never loads into the running state, but it will be responsible for the schedule dispatch, which means which is important first, which is not, right? These things. So here only the scheduling algorithms generally come into the picture, for which we'll learn later. But we can simply remember that long-term scheduler take care from new to ready, short-term scheduler take care from ready to running. Now there is another scheduler which is medium-term scheduler, right? Medium-term scheduler generally take care of waiting and suspend wait states, where it will prioritize, it will take care of the processes so that they can move forward on priority based, on ad hoc based, whatever we learn in the algorithms. So this was all about the process states, and schedulers. I hope you understand. Make sure you are remembering it so normally, because these are normal terminologies where you can, you can see that there are no complex words used, right? So I hope you understood. We'll get to know more further about the states and algorithms. Thank you so much.